Well, hello, all you cool cats and kittens. This is 15.2 to my sophomores. Angles in inscribed quadrilaterals is what we're doing today in our essential question right here. What can you conclude about the angles of a quadrilateral inscribed in a circle? So pretty much we know we're working with quadrilaterals, and inscribed means they're going to be inside the circle. So that is the theorem we're working with today. Okay, I just want to explore some relationships before we get started. One part of this theorem is, actually before I get that, let's break this down first. So we're working with this guy right here. The directions want us to measure it ourselves, but we do not have this in front of you to measure, right? So, and you don't have a compass in order to find those things. So I'm just going to give these to you. So angle A is 95 degrees. Okay. Angle B is 60 degrees. Angle C is 85 degrees. And angle D is 120 degrees. Okay, what I want to point out here, if you want to, you can pause the video and do all the math on this so you could explore their relationships. I'll do a few of them with you real quick. So we have angle DAB, so that's going to be 95, right? That's what it means. It's that number in the middle. 95. I'll put a 95 right here. Okay, and angle A right here, BC, which is 60 plus 60. So 95 plus 60 is going to give us 155. Okay, so if you want to explore some relationships in here, you totally can. You can pause the video and do the rest of these. I encourage you to. What you're going to find when you are looking at these angle measurements is that opposite angles, so I'm going to erase all this. I'm actually going to turn it blue. I'm going to keep my numbers here. Okay, sorry to readjust here. What I'm showing you here is opposite angles. So this guy, his opposite angle would be that guy right there. His opposite angle, 120, would be this guy right here. Okay, opposite angles they are called supplementary angles. I know like 8 of you are raising your hand. What's a supplementary angle? It means it makes what? Someone shouted out. Thank you, Ignacia. Yes, 180 degrees. Okay, that's supplementary angles. So whatever you have, 120 plus 60 is going to equal 180. 95 plus 85, 180. So that's part of the theorem too. When you're working and trying to find an angle, you have to know that these two angles add up to 180. Okay, so if we're doing some math on these, we can look and see. Let me scroll up. Here's the theorem right there. If a quadrilateral is inscribed, then its opposite angles are supplementary. That's the theorem we just went over. Okay. Also, if this side right here is 180 and this is 180, then you know quadrilaterals inside, it's going to add up the arc of BCD, okay, right through here, and the arc of DAB is there. Therefore, these two arcs, everything's going to add up to 360. Okay, here is where the book and I don't agree. I feel like that they describe this theorem a little tricky compared to the way I would describe it and break it down. So I'm going to say it in my own words. If you want to go through the interactive notebook, if what I say isn't making as much sense to you and you like the way that they teach it, you can go through the interactive notebook. I'm going to describe it my way, and so here we go. It's the same thing we learned in 15.1. what this is stating is we know still that whatever angle C is, its opposite arc, so this would be its opposite arc. This is angle C, right? I'm going to put red for its opposite arc. Red. Why won't you come? Okay, we might just get any color but blue. Bah. Alright, it's not letting me change the color. Alright, we're stuck with blue. Okay. Oh, never mind. Right when I said that. Okay, so what it's saying is DCB, whatever measurement is C, its arc, and this is going to be its arc, is going to be twice the measure, 2 times the measure of whatever this is, whatever this measurement is. So let's say that C was 50. Excuse me. If C was 50, this arc's measurement would be 100. If this arc's measurement were 200, this C would be 100. Okay, this is half of whatever this is. Okay, I will leave this up for you to look at if you want to pause the video and see their example, and then I will do one for you. I'll break this one down though. So what they're saying is measurement P and measurement R, P right here, and R add up to 180. They're opposite angles. Okay, so in order to find the value of Y, find the value of Y. We don't know what Y is worth, right? So we know that this guy plus this guy is going to add up to 180. So we put them together. We put 180 on the side. We combine all of our like terms. We know 5y plus 15y is 20y. We know 3 plus 17y is 20y. And then we got to substitute. So you're going to subtract 20 from 180. And then you're left with, so that would give us 170, right? And sorry, it's not a very good 7. 170, and then you have to divide the whole thing by 20. And that means y is 8. And once you know that, you can plug y in for all your guys down here to find the rest of the measurements. So go ahead and pause the video at any time if you'd like to look at those examples. Thank you for the 3 of you that paused to record those in your notebook. Ooh, this is a fun one. It's got fractions. Everybody loves fractions, right? I know Gabby and Danny do, right? Okay, so let's break this all down here. We have the measurement of, oh, hold up, I'm getting a phone call. Pause. I apologize for that. I'm sure you guys all have your phones docked appropriately, right? No Snapchat. Okay. So the measurement of J and the measurement of blank equal 180. We know that because obviously we learned that working with the 2 angles that make 180. So I'm just going to put 180. And that measurement that works with that guy right there, we have J, his opposite is, the L is right here, but really it means like it's right here. That's what he's talking about. L is 180. Okay, now we have to do some fun substitutions in here. We got to put all their little numbers in here. So we have 39. Oh my gosh. 39, sorry, that's really bad handwriting here. Plus 7x and 6x. 15. Equals, well, 180. But Mrs. Robertson, where did you get all these numbers? That is a great question. I got these numbers from here. So I know that J is worth that much, 39 plus 7x. Right there. And 6x plus 15, that came from this guy right here, measurement L. In case you weren't listening 2 seconds ago, L's right here, but really it's saying that this is measurement L. I know L just needs to move a little over. Okay, now we got to simplify. So combine all of our like terms. I'm combining my x's first, putting them out front. I have a 7x and I have a 6x. That gives me 13x. Okay, and then I have 39 minus 15, because there's a minus sign right here, so that means that this is going to be minus, and that gives me 24. Oh no. Okay, and if I were to add those bad boys up, they're still 180. Okay, and then I'm going to subtract 24 from 180. That's going to give me 156. And I'm still left with 13x. I'm going to divide 156 by 13, and that's going to give me 12. Okay. Okay, so now I know x equals 12, so I can do some fun math with that one. All right. My j is 39 plus 7. I'm going to go look back up at j. It has a little x right there, so that's where I'm going to plug in my 12. Ooh. Okay, kind of looks like 112, but it's just 12. And then once I plug that in, I have 39 plus 7 times 12. My answer is going to be 123. Okay, and then same thing with measurement L. I'm going to go look right here, right? This is where he is. This is what L is worth. 6x plus 15. So I got to plug in my 12, my x, okay, for this guy right here. I'm going to do a little math on that. 6 times 12 minus 15. That's going to give me 57 degrees. But Mrs. Robertson, what about measurement K? It has a fraction. Have no fear. I feel like you guys should no longer fear fractions. We have done them and done them over again. It's the same concept. It's stuck with the one up top. So we have 20. 20 times 12. All right, 20 times 12 divided by 3. If you had your calculators out, you know that that was 80. Okay, measurement M. So, yeah, it's this. We'll go through all of them. Okay, so measurement M plus measurement. Okay, let's look at measurement M right here. So if I want to find out what measurement M was, well, I know that this guy and this guy add up to 180. Okay, measurement M plus, I already knew what he was because I did the math on him a little earlier, and I found out that he was, I'm going to put this guy, K, sorry, we'll put K right here. Okay, we found out that K was worth, we already found out what K was worth. K was right here. So measurement M plus measurement K is 80 degrees, right? It's right here. And I know they're going to add up to 180. So I'm going to just do some subtraction on there. 180 minus 80, that's going to give me 100. Okay, so now I know every single one of these angles. If you want to fill those in, check your work with mine. Measurement J is 123. Sorry, 123. That goes right here. Measurement L is 57. Measurement K is 80. And the last one's 100. Boop. There we go. 100, not 108. 100. Alright. Alright, I'm going to do one more, and then you are free to fly. Okay, so let's work with what we know. I feel like I wrote all over there. Okay, so we had 12z minus 27 plus 37z, 37 plus 5z equals 180. Okay, so we just combined like terms right there, and we were left with, so that's how I rewrote it. So we just combined these guys. Okay, 12z plus 5z gives me 17z. Okay. Plus negative 27 plus 37 gives me 10 equals 180. Okay, I'm going to subtract 10. Cancels out, gives me 170. And I still have 17z right here. A little z there. So I'm going to divide this by 17. Okay, so then z equals 10. All right, now with all that information, I can go and I can plug z in right here. So I have 125 minus 10 gives me 115. So I know this guy's 115, right? And in order to find him, all I have to do is do 180 minus 115. Oh my. Because I know that these two sides added up together are going to give me, are going to add up to 180. So I just got to subtract one side from that. And once I do that, I get 65 degrees. So that's going to go right here. So now I know the measurement of all of them. 115 right here, 65 right here. If I wanted to define these, I just plug in for z. Okay, 10 in for z. And that way I can find all my sides. Okay, before I give you your homework, just so I know which one of you guys made it all the way through this awesome video with your favorite math teacher. Okay, I want you to post an unpopular opinion of something you don't like. Or I guess so it's unpopular. So that means I want you to say something that you don't like that everyone else does like. So if I were to comment in the comments below, I would put watermelon and seafood. Those are things that a lot of people like, and I always get crazy looks when I say I don't like those things. I don't like watermelon. I don't like seafood. So you need to post an unpopular opinion down below. If you do so, then you have one less problem to do on Seesaw. So that's how I'll know that you watched the video all the way through. So let's say I post 5 questions. If you comment below and I see that you watched my video, then you have one less question to do. So you only do 4 out of 5. You could pick which one you don't want to do. Put a star by the one you're not doing on Seesaw. So I know that you came down here, commented, and did that. All right. Have a great day, guys. Miss ya.